Good morning, and once again, welcome to my YouTube channel, Maths with Ease. And in this video, I want to respond to the question on the topic of volume and densities and capacities in Form 1, a KCSE question. And it's talking about an 890 kg culvert. 890 kg culvert is made of a hollow cylindrical material with outer radius of 76 centimeters and an inner radius. Let us have that culvert here. That is the outer and the inner. And then the culvert has to have a length. This outer is 76 centimeters and this inner is 64 centimeters. It crosses a road of width 3 meters. This is 3 meters. Determine the density of the material used in its construction in kilograms per meter cubed, correct to 1 decimal place. And what we have here is a cylindrical shape. Of course, it is hollow. It is hollow. There is the outer radius. I have to confirm this is the outer radius. The outer radius and the inner radius, 76 and 64 respectively. So we need to calculate the density. And as we know, density is mass over volume. So we have the mass, which is 890 kg. We need to calculate the volume. We can calculate the volume, which is the cross-sectional area times the height. That is what we are going to determine. And with that, we are going to find the density. Let us, first things first, we are expected to give our answer density in kilograms per meter cubed. So by all means, we must be able to calculate our volume in meters cubed because our answer is expected to be kilograms in meters cubed. That means we have to change all the centimeter dimensions into meters. For example, the outer radius is going to be 0.76 meters and the inner radius is going to be 0.64 meters. And what do we, of course, the height remains 3 meters. So let's talk about the volume. The volume is going to be the cross-sectional area, and the cross-sectional area is the area of the outer circle minus the area of the inner circle. The area of the outer circle, which is 22 over 7 pi r squared times 0.76 squared. This, you subtract the inner area, which is again 22 over 7 times 0.64, again squared. Once you utilize your calculator, you will get here 1.8153 meters squared. You will also get here 1.2873 meters squared. But let us just confirm that. 22 over 7 times 0.76 squared, you get 1.8153. Of course, 1.8153, and that is true. 22 over 7 times 0.64 squared, the radius 1.2873, and that is it. So this is also meter squared. So the cross-sectional area is this minus this, which is going to give us 1.8153 minus 1.2873, giving us 0.528. So the cross-sectional area is 0.528 meters squared. Now, for us to get the volume, we must multiply the cross-sectional area by the height. So the volume itself, the volume itself, the volume itself is 0.528 times 3. Then we multiply this by 3, so times 3. And we get 1.584, which gives us 1.584 meters cubed. This is the volume. Now, we all know that the density is given by mass over volume. And the mass is already given here. It's 890 kgs. And the volume we have obtained. So 890 divided by 1.584, which gives us, let's see, 890 divided by 1.584, we get 561.9. 561.9 kg for every meter cube. 5.561.9 kg for every meter cubed. Remember, it is to one decimal place. So our answer is 561.86. So the 6 now affects the 8 to become 9. And that is why our answer is 561.9. All right.